Okay, in the basic theory, we have discussed about motion into various categories. So motion could be with a constant velocity, then another with a constant acceleration, then third category was with the variable acceleration. So here we use v is equal to s by t. Velocity is equal to displacement by time or distance by time. Okay, so that is also possible. Then another thing was constant acceleration. So wherever constant acceleration is there, v is equal to u plus at, then v square is equal to u square plus 2as, then s is equal to ut plus half at square, then fourth category Sn is equal to u plus a into n minus half. Okay, so this much we have seen. Now third category is variable acceleration. If variable acceleration comes, definitely we won't be able to use all these equations. Here the only way is calculus. What is that? Calculus, differentiation and integration. Differentiation and integration. But this calculus can be used here also. Anywhere, whatever be the kind of situation, we can use integration and differentiation for doing the problems. Okay, so the basic formula for integration and differentiation is what? Suppose if you differentiate d by dt of t raised to n, what is that? N t raised to n minus 1. Same way, if when you differentiate t raised to n dt, how to differentiate t raised to n plus 1 divide by n plus 1 plus the constant. Okay, so this is the basic thing. I hope you might have watched those videos. If you have watched those videos, then you will be able to do all these problems fastly. Okay, so we will go to the very first problem. Okay, what is that? If x denotes x denotes displacement in time t, and x is equal to a cos t, then what is acceleration? Then what is acceleration? So you can do parallelly with me. If you are getting the answer, please comment whether with which option is this. Okay, so parallelly I shall do with you. Okay, so what is x? X is displacement, and x is equal to a cos t. A cos t. X is equal to a cos t. Okay, a cos t. So what is velocity? Velocity is equal to dx by dt. X is equal to dx by dt. So d by dt of what? A cos t. So differentiation of cos is what? Any idea?
Sin theta.
Minus a sin t. Minus a sin t. Okay. Now acceleration is what? dv by dt. dv by dt. That is d by dt of minus a sin t. Minus a sin t. So this is going to be what? Minus a cos t. So this is what is acceleration, option 2. If anyone got the answer, just please comment it. If you have any doubt, please ask. You can ask in the comment box. Or otherwise, if it is fine, we will proceed. Okay, got it. Anyone has any doubt in this? Any student? If anyone has any doubt, please ask in the chat box. If you have understood the solution, you can say whether I understood or not, because there should be some interaction. Okay, right. Okay, if anyone has any doubt, okay, any concern, should not hesitate to message our necessity. We should ask and proceed. யாருக்காவது ஏதாச்சும் சந்தேகம் இருந்தா கேட்கறதுக்கு கூச்சப்படக்கூடாது. Okay, any language, English, Malayalam, Tamil, any whatever language you are comfortable, you can write and ask. Or if you want to message, voice message, that is also fine. Okay, I'm moving to your next question with your permission. Next one. Yes, the velocity time relation of an electron starting from rest is given by u is equal to kt, where k is 2 meter per second. The distance traversed in 3 seconds is. Okay, so here velocity is given, u is equal to kt, where k is what, 2 meter per second, 2 meter per second square. So v is u is equal to 2t. This is what is velocity. Now what we need to find? We need to find the distance. So to find the distance from velocity, what is the formula? X is equal to integral velocity dt. X is equal to integral velocity dt. So this is equal to integral 2t dt. Now they have asked the distance traversed in 3 seconds. So from initial time is nothing but 0 to 3 seconds. So if you integrate this, this is going to be 2t square by 2, putting the limit 0 to 3. This 2 will be cancelled off. So this is going to be 3 square minus 0 square. So 9 meter is the answer, option 1. Okay, if anyone got the answer, please comment it. 9 meter. Subhashri is answering 9 meter. That is correct. Okay, good. Subhashri, good. Anyone else? Anyone has any doubt in this, or you are all comfortable? Shall I move to the next problem? This live session is for your doubt clarification. If while solving the problem, if you have any worries, then you can directly discuss with us, with the teachers. That is the reason live session is there. If you sit without asking doubt in live session, then you won't be able to understand the concepts well. Okay, fine. Everything is clear, then we can proceed. Okay. Third problem. Okay, the position x of a particle varies with the time t as x is equal to at square minus bt cube. At square minus bt cube. The acceleration at a time t of the particle will be equal to 0 when t is equal to. See, they have given like a x is equal to at square minus bt cube. That is position. The acceleration at a time t of the particle will be 0 when time t is equal to. What they are asking is, what is time t when the acceleration is 0? So from this position, we need to find acceleration, then equate acceleration to 0, find the value of t, we will be getting the answer. If you are getting the answer, please comment it. Okay, see children. Okay, so someone has answered, I believe. Option 3. Subhashri is saying option 3, right? Okay, we'll see. So x is equal to at square minus bt cube. So to find acceleration, first we will find velocity. Velocity is what? Differentiation of this position. So 2at minus 3bt square. Okay, now acceleration. Acceleration is what? Differentiation of velocity, dv by dt. So this is going to be 2a minus 6bt. Okay, now we will equate this to 0 in order to find the time where acceleration is 0. So 2a minus 6bt is equal to 0. So 2a is equal to 6bt. So what will happen? T is equal to a by 3b. A by 3b, option 3. So Shubhashri is correct. Okay, good. Any doubt in this? Anyone? Any worries? Any problem? Why can't we take like that? If you have any doubt, please ask. If you want to ask doubt, please unmute and ask. Or otherwise, keep it muted. Okay. Any doubt in this? So there is a disturbance, students. Whoever has not muted, please mute it. Please mute it. Some students, Kavya, can you mute your audio? Okay, so students, see, if you have any doubt, you can unmute and ask. Otherwise, it is better. You can ask in chat box itself. All other time, please mute your audio. Okay, next problem. Yes, a particle moves along a straight line such that its displacement at any time t is given by h is equal to t cube minus 6t square plus 3t plus 4. The velocity, what is the velocity when the acceleration is 0? They are asking the value of velocity when the acceleration is 0. That is, we need to find acceleration first. Then we need to equate that acceleration to okay. Then we need to find the first what we need to do, but find acceleration, equate acceleration to 0, then find the time from there. That time substitute in the equation of velocity so that we will get the velocity when acceleration is 0. Okay, fine. So displacement is given, s is equal to t cube minus 6t square plus 3t plus 4. This is what is displacement. Now we need to find velocity. Okay, so velocity equation will be what? Differentiation of displacement ds by dt. So this is what? 3t square minus 12t plus 3. This is the equation of velocity. Let it be there. Now we will find acceleration also. What is that? dv by dt. This is equal to 6t minus 12. Now we will equate this acceleration to 0. 6t minus 12 is equal to 0. Okay, some are answering. Some are answering. So those who got the answer, please comment. Okay, Sadhana is saying fourth option. Subhashri is saying minus 9 meter per second. Okay, both of you are giving same answer. Okay, any other options? If you have any other answer or the same answer, please comment this. Please comment. Okay, keep on. Please respond. So what we 6t is equal to 12 and we will be getting t is equal to 2 seconds. So acceleration will become 0 at a time t is equal to 2 seconds. So we will substitute t is equal to 2 seconds in the equation of velocity so that we will be getting the value of velocity when acceleration is 0. So 3 into 2 square minus 12 into 2, okay, plus 3. Correct. So this is 12 minus 24 plus 3. So simplifying this, we are getting minus 9 meter per second. Option 4 is the correct answer. Okay. So Sadhana, good. Subhashri, good. Rohit also answered. Okay. Any doubt in this? If anyone has any problem with integration, differentiation, okay, they will find it difficulty here. Okay. Shall we move to the next problem with your permission? Any doubt, any problem, please ask. Any concern? Okay, I'm moving. If you want to see any previous problem, if you have any doubt, please don't hesitate to ask. Okay, right. No doubt. Fine. Thank you, Manoj. Great. So we will proceed. So now this is the next question. The displacement of a particle starting from rest is given by S is equal to 6t square minus t cube. The time when the particle will attain zero velocity. Okay. So we need to find the time when the velocity becomes zero. Yeah, no worries. We can find it easily. So S is equal to 6t square minus t cube. This is the displacement. Now to find velocity, what? Differentiating ds by dt. This is equal to, different when you differentiate, this will become 12t minus 3t square. So at what time velocity will become zero? Okay. Okay. Subhashri saying 4 seconds. Okay, good. So any answer, if you are getting answers, please keep on commenting it. Okay. So time at which velocity becomes zero. Okay, so 12t minus 3t square is equal to 0. So 12t is equal to what? 3t square. So this t and this t will be cancelled off. T is equal to what? 12 by 3 is equal to 4 seconds. So option 1 is the correct answer. Option 1 is the correct answer. Okay, Sadhana answered correctly. Okay, Subhashri and Sadhana answered correctly. Okay. Is it clear, children, all of you? Are you able to understand? If you are able to understand, please give comment in the chat box. If you have doubt, please ask that also. Okay. If you have any, if you are able to understand, please give me a comment. If it is everything is fine, just say at least clear, no doubt. Comment something. I need response from you.
No doubt, sir.
Okay, fine. Bharati, Megavardhini, fine. Srinidhi, fine. Pujana, oh, right. Rohit. Okay, thank you, students. Okay, fine. Then we will proceed. Okay, right. Next problem is this. Okay, the velocity of a body depends on time according to the equation v is equal to 20 plus 0.1 t square. The body has, they are asking whether it is uniform acceleration or uniform retardation, non-uniform acceleration, zero acceleration. Okay, so velocity is given. Velocity is what? 20 plus 0.1 t square. Now the option is all about acceleration. So let us see what is the acceleration. Acceleration is what? dv by dt. So when you differentiate this, this will become 2 into 0.1 t. So acceleration is equal to 0.2 t. This means a term t is there in the equation of acceleration. Suppose if acceleration is equal to 10 meter per second square, we can say this is uniform acceleration, or we can say constant acceleration. Correct or what? When term t comes, what is the problem? Option C. Subhashri is saying option C. Okay. Okay. So when t comes, what is the problem, children? That is a is equal to 0 at a time t is equal to 0. When you substitute time t is equal to 0, acceleration will be 0. At a time t is equal to 1, a will be 0.2. At a time t is equal to 2, a will become what? 0.4. So acceleration is non-uniform. Option 3 is the correct answer. Okay, when t is there, when you make t is what? Time. So when you make changes in the time, that is 0, 1 second, 2 second, 3 second, this value is changing. So acceleration is neither not constant, or we can say this is not uniform, non-uniform acceleration. Okay, is clear? Okay, next problem. The initial velocity of a particle, initial velocity of a particle is u. Okay, at a time t is equal to 0. And the acceleration is given by f is equal to at. Which of the following relation is valid? I will give you 2 to 3 minutes. Can you comment your answer? I will wait for your answer for this one. All of you, please respond. Okay, Subhashri is saying option 2. Option first, you said option C. No, option 2. Okay, any other answer? Sadhana, Mukund, Nitish, Kavyamzu, Blesson, Haripriya, Harshiga, Harshit, Karishma, Megavardhini, Midun, Pujana, Rania, Rohit, Ritika, Manoj, Sri Varsha, Shreya, Sri Prasanna, Sri Nidhi. Okay, Pranya is saying option 2. Bharati feels like option C. Maybe option 3. You might be thinking option 3. Sri Varsha is saying option 2. Yes. Okay, we will do. Now here, okay, some other answers also. Okay, Megavardhini option 2. Okay, let us see. Okay, so here the initial velocity is given as u. Initial velocity is given as u, and f is nothing but acceleration, which is given as at. Okay, this is acceleration actually. They have given like a acceleration is given by at. Okay, now what is this acceleration? This acceleration is actually dv by dt. Okay, differentiation of velocity with respect to time is what is acceleration. dv by dt is equal to at, we can write. So dv is what? At dt. At dt. Now in order to find velocity, okay, the relation is based on velocity, we need to integrate. So integrating from 0 to v dv, on right side integrating from 0 to t, because this is dt, so at dt. Okay, so when you integrate this, we will be getting here, we will be getting v is equal to what? A t square by 2. So then putting the limit 0 to t, finally we will be getting v is equal to what? A t square by 2. Okay, so here 0 to, instead of 0 we need to write u, because they have given like a initial velocity is u, not 0. Okay, so we can write here v minus u. Okay, this left hand side is v minus u. So v minus u is a t square by 2. So v is equal to what? U plus a t square by 2. Okay, so option 2 is the correct answer. Option 2 is the correct answer. Clear? All of you? Okay, Ritika, option 2. Okay, so hope everybody understood the answer. Most of you have already done. Good. Okay, we will move to the next problem. Okay, so yeah, this one is a particle located at x is equal to 0 and at a time t is equal to 0 starts moving along positive x direction with a velocity v, which varies as v is equal to alpha root x. The velocity of the particle varies with the time as whether v is proportional to t or root t or t square or velocity is constant. This is what they are asking. So this question is a good question. They have given like a v is equal to alpha root x. So v is given in the form of what? Or in terms of displacement they have given, or in terms of position they have given velocity. Generally velocity will be given in terms of time t. Now they have given in terms of position. So we have to make it in terms of time, then only we will be able to do this. So v is equal to alpha, instead of root x, I am putting x raised to 1 by 2. So we know velocity is dx by dt. So dx by dt is alpha x raised to 1 by 2. Now I can write dx by x raised to 1 by 2 is equal to alpha dt. Alpha dt. Now integrating, okay, from 0 initial position to position x, dx by x raised to 1 by 2 is equal to, integrating the right hand side from 0 time to time t, alpha dt. So here I could, when I integrate this, I can write like x raised to 1 by 2. This is actually x raised to minus 1 by 2 when it goes up, plus 1 divide by minus 1 by 2 plus 1. Right hand side, this will become alpha t. So this is nothing but x raised to 1 by 2 by 1 by 2 is equal to alpha t. Or I could write x raised to 1 by 2 is equal to 1 by 2 alpha t. Now if we square this is nothing but x is equal to alpha square t square divided by 4. Now we got the position in terms of time. Now in order to find velocity, v is equal to dx by dt we can do, and d by dt of what? Alpha square t square by 4. So this will become alpha square by 4 into 2t. So from this we can write v is proportional to time t. Option 1 is the answer. Is that clear for all of you? Did you understand the solution? So option 1 is the answer. Okay, so this is our last question. If you have any doubt in this, you can ask. Otherwise, we will wind up the session. Okay, so I got the velocity in terms of position. I converted this in terms of time t, found the velocity, found the relation of velocity with the time. Okay, any doubt is there? Okay, I'll explain once again. Okay, see, v is equal to alpha root x. This is given in the question. What I did is root anything, like a root of anything is nothing but we can write, if it is root 2, then we can write 2 raised to 1 by 2. So v is equal to alpha x raised to 1 by 2 I wrote. Now velocity we can write as dx by dt. This the differentiation of position or differentiation of displacement. Likewise I can write dx by dt is equal to alpha x raised to 1 by 2. Now I rearranged it, x terms to one side, time term to other side, then I integrated. When after integration, I got everything in terms of time. That is x raised to 1 by 2 by 1 by 2 is equal to alpha t. So x raised to 1 by 2 is nothing but root x. So when I square this, I'll be getting x is equal to alpha square t square by 4. Once I get the position, when I differentiate, velocity v is equal to dx by dt, I can find the relation of velocity with the time t. Is it okay? Clear? Blesson? Okay, fine. Okay, children, then we'll wind up the session. We'll see you next week. Okay, thank you.
Thank you, sir.